Yep, when you're working in a vacuum and you're inside a spacesuit with oxygen, you don't want to cut your glove because then the oxygen will leak out and then you die. So that's a bad day.
It's suboptimal.
Hi, I'm John Grunsfeld, NASA astronaut.
Hi, I'm Christy Hansen, NASA astronaut trainer for spacewalking and flight controller.
I'm Ed Rezac, EVA engineer for the Hubble Space Telescope project.
Now, EVA is an acronym that means extravehicular activity, which is just a fancy way of saying spacewalk. And I was lucky enough to do 8 spacewalks on the Hubble Space Telescope, working with Christy and Ed. The Hubble Space Telescope was designed to be upgraded and fixed on orbit. Occasionally, something would break that wasn't anticipated, and we had to come up with new ways of fixing it. And that was the case on this last mission, the most ambitious of all the Hubble missions, and some of the most difficult spacewalks ever done. The Space Telescope Imaging Spectrograph failed, and we had to figure out a way to fix it on orbit, rather than putting in a whole new scientific instrument, which is what we usually did on Hubble. Unfortunately, the designers of the Space Telescope Imaging Spectrograph never imagined that we would have to open it up in space. And it had hundreds of tiny little screws that we had to remove to access a circuit board to replace it, to bring the instrument back to life. So these are some of the tools that we came up with to be able to do that.
We tried to make the tools as astronaut friendly as possible, and one way we had to do that, or that we chose to do that, was using colors to color code the different size fasteners and the fastener bits so the astronauts could easily grab what they need and proceed with the task.
How do we pick up an interface and not lose something in orbit? Bit caddy. Which one do you want, John?
I'll take a red bit.
Okay.
Now John's going for the red bit. This had several different fastener types that had to be removed, which required different bits. And the fastener capture plate, which held all the fasteners and kept them from drifting into the optics core of the telescope, was also color coded. So John could match the bit up with the color code on the plate itself.
So we installed this fastener capture plate on the front of the STIS Space Telescope Imaging Spectrograph instrument. And the reason why we had to use the fastener capture plate is, as Ed said, if I were to remove a screw and let go of it and it floated away, it could damage the telescope. So all of the screws were behind this plate.
And you had 111 chances to lose screws.
And you would insert the bit through a tiny little hole on the fastener capture plate, engage the head of the screw, undo it, and then when you take the bit out, the screw would float around inside of this little cavity, and the screw was big enough that it wouldn't fit through the hole, and then repeat 111 times.
And how do we track all of that, John?
Well, like any good spacewalk, we had a set of procedures that you helped write.
Exactly. So we had a whole ground team associated with developing the procedures, capturing all the requirements, and flying as an EVA spacewalking checklist on orbit. So when John and Mike Massimino, who actually performed this task on spacewalk number 4, removed each one, we had a requirement that he actually read to the ground, okay, I'm releasing screw number 1, and we would all be on the ground, check screw number 1. Now screw number 2, 111 times to make sure that everything was fully released so that when he went to remove the interface, nothing was stuck. It wasn't stuck onto the telescope.
Really amazing, all the complexity to do something as simple as removing hundreds of tiny screws so that we could get access to the circuit board and use another tool to pull it out, put a new one in, put a new cover on with no screws that locked on, and bring that instrument back to life so it could continue looking at black holes and the distant universe. Really pretty amazing. All worked out great.
And in addition to what John said, the astronauts had to be trained on stay away from this, don't touch that. They're taking something off and handing it off to another astronaut. They have to make sure that they don't cut gloves in the process of doing those transfers. So all that is designed and trained into the repeated training tasks so they have this muscle memory to be careful every single time.
Yep, when you're working in a vacuum and you're inside a spacesuit with oxygen, You don't want to cut your glove because then the oxygen will leak out and then you die. So that's a bad day.
It's suboptimal.
Thanks for joining us on Hubble Tool
Thank you.
Time.
See ya.
I like all the pretty colors.
That's pretty stable.
That's not bad at all.
Kind of boring.